Hello, Bearcats. In this section, we're going to talk about evaluating trig functions of any angle. So let's review what we know because we want to remember what we know about our unit circle as well as what we know about right triangle trig. So we've got a lot going on here. So I'm going to go ahead and draw my axis. I'm not going to put all the degrees and radians on here, and actually I'm really talking about radians now more than anything. I am going to put my big 4. And these are things that you should be practicing. So we know this is at 1, 0, 0. Over here we'd be at negative 1, 0, 0. At the top we are at 0, 1, undefined. And at the bottom we are at 0, negative 1, undefined. We know we're at 0 radians. We're at pi over 2 radians. We're at pi radians. And we're at 3 pi. Oops. Over 2 radians. And then for our reference angles, which are the most important, we're at pi over 6, and then we rotate 45 pi over 4, and 60 is pi over 3. I'm going to go and put my reference in here. Just again, you're going to start to be able just to think about your reference angles and not have to write them down. But for right now, let's go ahead and do that. So at 30, where would be 6 pi over 6, at 45, 4 pi over 4, and at 60, 3 pi over 3. And of course over here at 360 or 2 pi, we would be at 12 pi over 6. We would be at 8 pi over 4, and we would be at 6 pi over 3. And those are all our reference angles. I'm going to put up here my values for cosine, sine, and tan. I'm going to put them in sort of this order. Remember, at 30 degrees or pi over 6, we are the square root of 3 over 2, 1/2, and the square root of 3 over 3. Putting us at 60, 1/2, square root of 3 over 2. Remember, they flip-flop, and then just the square root of 3. And of course, at 45, we're the square root of 2 over 2, the square root of 2 over 2, and 1. So there are our values. Also, you can put this all on one grid. There's all sorts of ways to put this for yourself, so put it however it makes best to you. I'm going to go ahead and remember cosine, actually sine and tan. For cosine, be careful, it's adjacent over hypotenuse, which we know is adjacent over radius. For sine, we would be opposite over hypotenuse or opposite over radius. And for tan, we would be opposite over adjacent, which would be sine over cosine. That's important. And then we have our reciprocal identity. So besides cosine, we have secant. Friends with sine is cosecant, and friends with tan is cotan. So everything would just flip around. I'm not even going to write that down, except I will write the cotan is cosine over sine. Oh, let's go ahead and do that. So it's hypotenuse, our radius, sorry, let's do r over opposite, and this would be r over adjacent. That just gives us all the little review things that we are supposed to know now before we start to evaluate for any angle. Remember, if it is a value that you recognize or a denominator of a rotation that you recognize, please use your unit circle. Just use your knowledge that you have. That will save you time, it will save you energy, it will save you work. But if it is not, then you will need to use you'll need to draw the triangle in the correct quadrant and go ahead and do Pythagorean theorem if you need to, and use your right triangle trig. Let's look at just 3 examples, and then we'll do a lot of practicing tomorrow. So let's look at our first example. Okay, in this first example, they give us a point on the terminal side of theta, which would be a point on the circle at negative 3, 4. Okay, that point is not like the square root of 3 over 2, 1/2. It's not something that we recognize. So we will need to draw our triangle and use our right triangle trig. So I'm going to go ahead and draw my axis. Understand that probably, I would still say 70–80% of the time you'll get to use in the future, you'll get to use your circle key values, your key angles, but sometimes not, so you have to know both. All right, so we're on the terminal side of theta, and we're at -3. We're just going to pretend like we're mapping that point. So we would go a distance of -3, a distance of +4, and then we would go ahead and draw our triangle. This is -3 and +4. Well, you know this is a triplet, 3, 4, 5. The radius would be 5. If the legs are 3 and 4, then you know the radius is 5. Okay, so now we have everything we need, and we're really just answering questions based on that knowledge. So for sine we know is opposite over the radius, so it'll be 4/5. Cosine is adjacent over the radius. I'm going to keep writing this down, help you remember. -3/5. And tan is opposite over adjacent. I'm going to write down sine over cosine. That's going to become very important soon, that you really have that connection. So let's keep writing it down. And sine would be our y value of 4. Cosine would be our value of -3. So -4/3. All right, and there's the first one. Not too bad if you know what your circle and you know your right triangle trig. Let's look at number 2. Okay, in the second example, again, we see that we have a given tan theta of -5/4. So our given tan theta, remember theta would be our degrees or radians, so this has to be our value. So it is not the square root of 3/2 or 1/2 or the square root of 3/3 or 0 or 1, or so it's not something we recognize. So again, we would be building a triangle in the correct quadrant and then using our right triangle trig. So let's go ahead and do that. So we got to also pay attention to this right here, because this tells us tan is negative. Well, we know from all surfers to California that tan is positive in the first and the third. So tan could only be negative in the second and the fourth. But we have 2 locations. This second restriction right here, and we have to pay attention to, is going to tell us which of those 2 quadrants are in. This says our cosine value is greater than 0, or our cosine value is positive. Well, cosine can only be positive in the first and the fourth. So guess what? We get double check marks here. This is where we will be building our triangle. So we're going to go down, we're going to just build our triangle, and we're going to assume that this is tangent, which is sine over cosine, are opposite over adjacent. So opposite, we're going to assume -5. My triangle certainly does not resemble that, so it's not a scale triangle, because this should be bigger than, and then this would be 4, and this would be 4. So be careful. This is not a 3, 4, 5 triangle, because your radius cannot be larger than your sides. So let's go off to the side and figure out how we find that. So we would have 4 squared plus -5 squared equals r squared. That would be 16 plus 25 equals r squared. Well, 16 plus 25, I believe, will be 41. So 41 equals r squared. R equals the square root of 41. So up here, this is the square root of 41. All right, now we have our right triangle all built out. We can answer any of the questions. So the first question is sine theta. We know sine theta is opposite over radius. So opposite would be -5 over the square root of 41. So a -5 over the square root of 41. We would, 41. We would need to rationalize our denominator by multiplying by the square root of 41 over the square root of 41. And we would get -5 root 41 over 41. Yippee. All right, secant. Secant is friends with cosine. You know cosine is adjacent over radius. So secant is radius over adjacent. I always do this to keep reinforcing what I know. That's really important that you think that way. It will help you long term tremendously. All right, so radius, the square root of 41 over adjacent, which is 4, and there is our answer. Go Bearcats. All right, one more example, and then I think we'll just be ready for lots of practice. All right, in this third example, they give us that what quadrant we're in, so we'll certainly, that's a hint to build our triangle. They also tell us sine is 1/3. Okay, so sine usually in our special angles would either be 1, -1, or 0, and or undefined, or it would be the square root of 3 over 2, or 1/2. So that's not one of those values. So we will be building a triangle. And we're going to be building it in the third quadrant because we were given that information. And make sure you remember in the third quadrant both your cosine and sine values are negative. So sine, remember, is opposite over radius. But if that's true, this would be 1 and this would be 3. But this one has to be negative. Even though it's not showing up here, it would have to be negative. So our sine value would have to be negative. I don't know why they didn't tell us it was negative. Oh, that's because Miss Orrin wrote it in the wrong quadrant. Sorry, hold on. Okay, I'm back to, this should have been quadrant 2. That was my error. So I'm going to start over with that. But notice how we caught that mistake, because we know that sine can't be positive in the third quadrant. So sine would be in your second quadrant. We build a second quadrant triangle. Sine is still opposite over radius, so 1 and 3. And now we would just need to find our cosine side of our triangle, or our missing side here. So we would have 1 squared plus the cosine side squared equals 3 squared. So we would have cosine side squared equals 9 minus 1. Cosine side squared equals 8. Square root cosine is going to be the square root of 8. And you can reduce that. Again, remember 2, and that would be 4, and 2 would be 2. Oh, look, a pair of 2's. So this would be 2 square roots of 2. All right, so our missing side is 2 root 2, but guess what? It's negative in the second quadrant because remember, all surfers to California. So sine is positive, cosine would have to be negative. Tan will also be negative. So immediately, I know cosine and tan are going to be negative, so I'm going to go ahead and just put my negative signs there. That is the thing that you most get docked for on a test, is that you forget your sign correct signs, and that puts us in the wrong location. So it really the entire thing is incorrect. And you know, a little bit later on we'll just count them completely incorrect. Right now we'll give a little leeway, but you really need to practice and work on what quadrant and what the value of the sine value is. All right, cosine we know is going to be adjacent over radius, and so that puts us at a negative. Adjacent would be negative 2 square roots of 2 over 3, and there's your first answer, which is pretty easy. No rationalizing involved. And tangent is going to be a negative opposite over adjacent, or sine over cosine. And so we're going to have a negative opposite, which would be 1 over 2 root 2. Now, let's skip over here and let's look how to rationalize that. So we have a negative 1 over 2 root 2. We only need to multiply by the root, so the square root of 2 over the square root of 2. So now at the top we have the negative square root of 2. At the bottom, this is going to become 2, and 2 times 2 is going to become 4. And so negative root 2 of 4 is square root of 2 of 4 is your answer. And I would say that's a wrap. Go Bearcats. Lots of practice tomorrow.